The axis of rotation of the Earth deviates, and these are the three reasons. The average displacement was around 4.2 inch per year during the past century, and scientists believe that the process may be accelerating. During the 20th century, the axis of rotation of the Earth accumulated a displacement of more than 10 meters, as has been established by a group of scientists from the Jet Propulsion Laboratory of NASA. The researchers highlight Greenland's melting among the causes of this inclination, but admit that there are also two other very relevant ones. The process called glacial rebound is a traditional explanation of secular polar displacement, said team leader Surendra Adhikari, whose words are collected by the EarthSky website. However, it can be attributed only about a third of the axis movement produced in the last century. Exact moment: an iceberg of more than 6 km emerges from a glacier in Greenland. Another factor is the convection of the mantle, the terrestrial layer located below the crust. This process is due to the long-term mass movement, which is a key mechanism to promote the migration of the axis. Meanwhile, the mass loss of Greenland's glaciers and, in general, the melting of the global cryosphere is especially current for the decades marked by climate change. The group estimates that this factor will still accelerate the detour in the near future, which during the last century occurred at an average speed of 10.5 centimeters per year. It is a geometric effect of mass redistribution, another member of the team, Eric Evans, said in a comment. If you have a mass that is 45 degrees from the North Pole, which is Greenland, or from the South Pole, like the Patagonian glaciers, it will have a greater impact on the axis of rotation of the Earth than a mass that is just close to the pole, he explained. The three main causes have been identified thanks to an interactive simulation of polar movement, which is the result of a combination of 283 models of different cryospheric, hydrological, oceanic and seismogenic processes on Earth. A summary of the scientific article, which the Earth and Planetary Science Letters magazine will publish next November, details that they are sophisticated models that recently appeared and reconstruct the tectonic plates, along with geoid and seismic tomography models. The term global warming has a reassuring, comfortable sound, writes Jim Hansen. But paleoclimate data shows the reality could be anything but, with rapid climate oscillations, large, abrupt rises in sea level, major disruptions to ocean circulation, and massive superstorms. It may already be too late to forestall this dystopian future. Approaching a point of no return. The relevance is that I believe we are already witnessing the beginning of this cooling southeast of Greenland and cooling around Antarctica in response to fresh water from ice melt. In that case, observed cooling southeast of Greenland and the extra warming along the United States east coast are not natural fluctuations. When AMOC slows down, it causes both of those. This interpretation implies that Greenland meltwater is already having significant effects. The warm water along the east coast is the reason that Sandy retained hurricane force winds all the way up to the New York City area. The nearby Atlantic was about 3°C warmer than normal. This unusually warm ocean water has also been able to provide the moisture for record snowstorms in recent years. Is our world in danger? The influx of fresh water from shrinking ice sheets also causes the planet to pitch over. Landerer and colleagues estimate that the melting of Greenland's ice is already causing Earth's axis to tilt at an annual rate of about 2.6 inch, and that rate may increase significantly in the coming years. During this century, ocean warming will make the North Pole's spin axis to move towards Alaska and Hawaii about 1.5 inch per year. The newly redistributed mass will also make our planet to spin faster.